Well, thank you all, and thank you for joining us here this morning. If we can get the slides, switched over. There we go. Well, almost. Well, anyway, this conference is about you, and you all actually are quite an amazing group of people. You're doing hard work. You are solving many of the difficult problems that we all face around the world. I'm going to take a minute, maybe two, to do something that is very traditional for us, and that is that, as Gendra mentioned, we're all here to learn from each other, to share. But it turns out that we actually learn a lot more from our friends. And so part of what I'd like to see happen here over the next couple of days is for you all to become better friends. So let's take a minute and actually stand up, turn around, and meet somebody new. Tell them who you are and what you do, and do the same with them. Okay, everybody, take a moment. All right, well, thank you. Okay, thank you. Do you see how that works? Isn't it amazing? This is actually the interactions and the sharing, developing of friendships, trusted relationships that actually helps this community get things done. And you all are an important part of a global community of GIS professionals that actually is powering all of those things that Gendra was talking about just a few minutes ago. And so your work is actually quite extraordinary. You are actually applying the science of where to all the difficult challenges that we face every day. You're working in natural resource management, which is sort of the basic fundamental industries that power the world. You're also managing and analyzing land information, and actually even in industrial land planning right here in India. Also, we heard about smart cities, and this is actually about 3D buildings and city modeling, and doing this actually in lots of detail to understand exactly how things work and to make things more efficient. Transportation planning and management. Those of you who are here in the Delhi area know better than anyone else in the world how much time and effort and energy and pollution actually can be reduced by proper transportation planning and management. You're working on engineering and public works to create infrastructure that supports everybody throughout the country. You're also planning and managing utilities and telecommunications, and actually managing and engineering the important communication networks that connect up everybody. Some of you may have actually looked over here on the right and caught this other application down here on augmented reality from one of our organizations in New Jersey, Augmented Reality. Imagine actually being able to take your smartphone and scan, but overlay on top all of your assets and network information. So you're not lost anymore. You can find things right away, get oriented, and be more effective in the field. Our cities, of course, are growing. They're becoming overcrowded. How do we actually design the cities of the future? The whole initiative of smart cities is something here in India is something that the whole world is watching very carefully. And of course, business analytics and location intelligence, creating more competitive businesses and actually allowing every citizen, in a sense, to participate in the economy, actually with this financial inclusions work that's being done as part of NIC here. And of course, keeping our citizens safe and secure is something that allows us to live and thrive in an open way. Of course, for me, coming from a place like California, it's one disaster after another. The wildfires, the earthquakes, the hurricane-force winds, climate change, floods. How do we actually get prepared for that? Even here, wind cyclone zones and planning for and preparing for natural disasters. It's a critical aspect of being resilient. Again, we talked about this new trend, actually, for engaging citizens, this idea of participatory government. It's a whole new way, and it's a new trend that is actually happening right here in India as well. One of the ways that we learn and communicate the best is through stories. And if you haven't already looked at this, I really urge you to look at story maps. Tell your story. Teach others about the work that you do. And help them understand more deeply and more completely the work that you do and how it impacts the world around us. So our world actually is undergoing a massive digital transformation. You know, we talk about it sort of in a simple way, but this is actually an amazing trend and it's happening everywhere. The science of where, as Agendra mentioned, is actually a fundamental digital language for helping us understand and manage our world. And you all are the practitioners of the science of where. The science of where actually provides a framework and a process. It's really quite amazing. It's actually built in to the science and the technology. This idea of creating understanding by managing data and integrating it, being able to visualize and map it, being able to analyze and model and predict, and then collaborating to design and plan a different future, supporting decisions, informing the public, changing policies, and then taking all that to action. It's actually transforming the way we think and the way that we act to create a more sustainable future. GIS, it turns out, is the platform for managing, analyzing, and applying geographic information. It's kind of interesting, but actually it allows us to integrate people, processes, things, and all the data about them. Most of you are involved in managing systems of record, the authoritative content about assets and resources, and doing that on a transactional basis. It was actually one of the first patterns, really, of applying the science of where. There's a second kind of system that GIS is particularly good at, and that is actually looking at GIS as a system of insight. That is, doing analytics, diving deep, and analyzing all the information and content, like Agendra talked about, to bring new insights and new ideas, an understanding of new patterns and behaviors. And then there's a third type of system, actually, that's supported by the Arcgis platform, and that is a system of engagement. That is, creating new types of interactions and collaborations, both within your own organizations and work groups, and actually beyond with citizens, constituents, and customers. All three of these work together, actually, to apply the science of where. So GIS actually doesn't really stand alone as a technology. It's built on top of other technologies that are enabling us. Again, we talked about all the different types of data and data streams coming from everywhere, real-time information, scientific observations, imagery, 3D, traffic information from sensors. Also, the computing infrastructure that connects everything up and actually gives us distributed computing and pushes it all in to this new thing that we call WebGIS. It's actually a new innovation in GIS that some of you are beginning to experiment with today. But it actually is really expanding the power of GIS by leveraging these technologies and web services and the distributed data and computing resources everywhere. WebGIS is therefore a modern GIS architecture. It actually leverages web services and it enables individuals, teams, departments, and entire organizations. And what we're seeing here in India in particular is actually exponential growth in the adoption of this technology. WebGIS actually simplifies working with all types of data, imagery, tabular and business data, our traditional GIS vector data, actually bringing everything to life in 3D. Also getting feeds from sensor networks and real-time data observations. Also being able to take these big data repositories and plug into those to extract information at will. And also other measurements, high accuracy like light, all coming together. So I mentioned this idea of real-time information, leveraging dynamic data about everything, both the built environment, the natural environment, all types of sensors coming at us through the Internet of Things. And organizing all of this into information that's important for the work that you do. Apps, of course, make all of this come to life. Apps for the field, apps for business, apps for designing and creating, apps for viewing information in simple ways, integration of social media and crowdsourcing, story maps, as I mentioned, and of course, dashboards that give us the operational intelligence that allow us to access all of this information broadly throughout an organization and beyond. Also, WebGIS is making spatial analytics far more accessible than ever before, both from exploratory data analytics to understand the individual systems that we're working on ourselves, and then also opening up access to other analytical systems like machine learning and artificial intelligence and sophisticated analytics from statistical packages like R and others. Actually leveraging data science and allowing data scientists to leverage GIS. It's actually kind of an interesting notion of connecting these worlds. And of course, we want our mapping to be smart. Simplifying the use of these visualization tools to actually create more meaningful information right from the start. And GIS is also revolutionizing how we plan and design. This concept of geo-design, it's actually integrating science and information into the design process itself. So from the very start, we're creating something that's more sustainable. WebGIS is moving into actually a whole new realm. It's about connecting everyone. In a sense, creating not just a GIS for us as professionals, but actually creating a community GIS through this system of engagement that I mentioned before. So this is actually a new pattern. It allows us to take our authoritative content, open it up, and engage with citizens communicating in a more effective way. It allows us to tell our stories. And it's actually engaging new parts of the communities, like startups, like academia, like citizens who are contributing into actually this community GIS. So WebGIS actually is allowing us to take GIS to a whole new scale and actually creating something that is not just one system for us, but it actually is allowing us to interconnect systems into something that we're calling now a system of systems. Kind of an interesting notion. So actually now it means that GIS allows us to do our work better. It allows you to more effectively apply the science of where and to do that more broadly and at a whole new scale. Let me talk now about the work that my colleagues are doing to build new capabilities into the Arcgis platform. So first of all, I want to just talk about Arcgis, which actually is our product. It actually is this new services-based, as I mentioned. It's deployable on premises and also in the cloud, and actually the most popular pattern in a hybrid form. It is powered by distributed systems and has applications on the desktop, applications for the web, applications for devices, and APIs that are open and allow you to connect and interoperate with all types of systems. There's something that I want to focus on here, and that is that sitting on top of all this is something called Portal for Arcgis. This portal actually is an important part of the system. It actually manages what we call the geo-information model. It manages all the information about apps and workflows and models. It manages all the data and services. It manages maps and charts that are ready to use. It manages the metadata about those data and maps. It also manages information about your organization, your organizational structure, and the people and the identities and roles within it. It actually allows you then to discover, use, make, and share any kind of map on any device, anywhere, anytime. Kind of an interesting idea and a whole new way of organizing all of the geographic information about our assets and resources around us. Arcgis continues to support multiple patterns. The desktop pattern, of course, that we're most familiar with. Also, client and server architecture for managing the authoritative systems of record. Also extending into enterprise information and also leveraging the online resources. And this new pattern that I mentioned, the systems of systems, which is actually distributed systems interconnected through portals. A new, interesting idea for interconnecting everything. So let me dive a little bit deeper into the actual capabilities and how those are advancing and innovating through time here. I won't spend too much time on this, but Agendra actually gave a great rundown about all of the content that's part of the Arcgis platform. It is arguably the foremost collection of global geographic information, and it really is becoming a living atlas for the planet. Of course, it's not just us working in an office anymore. That pattern, of course, is still there, but taking GIS out of the office into the field to exchange and use information in a much more effective way, right at the source. So great apps for exploring, for managing workforce and tasks, for finding the places that we have to go to investigate, collecting information about it, and then bringing it back, being connected or disconnected, as the case may be. One of the important patterns and capabilities of ArcGIS is actually managing and compiling information to manage these authoritative systems of record. CAD integration, improved editing, a new utility network was actually just released, the first release, kind of interesting. And then also improved geocoding, location finding, and many other improvements. Of course, mapping and cartography, which is how most of us express our work to others. Smart mapping, improvements in Pro for map production. Also, production charting and mapping for those of us who are producing lots and lots of authoritative content. Also, more efficient ways of taking the information offline, like vector tiles. And for those of you who are into high-end cartography and publishing, the ability to take your information into Adobe Creative Cloud and do that in a very effective way for publishing both print as well as online. ArcGIS is 3D. ArcGIS is a 3D platform. ArcGIS is a 3D GIS. Pretty soon we won't need to say that anymore. But the idea is that it's not just 2D and 3D as a separate thing. Actually, ArcGIS supports 3D natively for photogrammetry, for GIS data, oblique imagery, LiDAR, and now new integrations with CAD and BIM. This is used in visualization, used in urban planning and design, used throughout all the applications, and also new data types and innovations for virtual reality, mixed reality, and so on. I'm going to quickly mention something that is new in the works. This is actually a new type of collaboration and partnership between Autodesk and Esri. The whole purpose of this collaboration is to integrate BIM and GIS workflows, make them work seamlessly. This means working in the planning frame and GIS informing the design process, and then to the design and the build process feeding right back in to a product life cycle to manage an entire portfolio of projects, not just a single one. What are you saying? I'm sorry. My receiver? You can't hear me?
No, it's creating some disturbance. Every time you move your hand, the cord rubs against it.
Oh, it's the cord. Is this better? Okay. Okay, ArcGIS is an imagery platform. This means that it is not just something to use as a backdrop, but it's a complete image management platform. It provides advanced processing and analytics. That's me? Can't be. I'm not moving. Okay. I can switch to these mics, other mics. Is this better? Is this better? Okay. Better? All right. So, Imagery. It's an image management platform. It allows real-time processing. It allows integration of other image services with our great partners like Harris, and full motion video, all into a single system. This means that you can actually capture imagery from live sources in real time, add them to a massively scalable libraries, process them, and deliver them on the fly. Spatial Analytics is also continuing to evolve and improve. This is actually now not just on the desktop, not just on the server, but also on the web. We have better science integration through Python APR and connections out to R. Also, improved processing using big data analytics in parallel processing, and many, many other enhancements that you'll learn about throughout the conference. There's a new product also called Insights for exploratory analytics. It actually is about creating a whole new experience for those of you who want to do spatial analysis and look for new trends. I'd like to now turn over for a short demonstration to my colleagues Krishna and Assad. Gentlemen.
Yeah. Thank you, Dean. Good morning, ladies and gentlemen. There is a famous quote from the author Dave Prager. He says, every time he left his Delhi flat, he comes back with more questions than the answers. He's talking about the second most populous city of India. You know, he talks about this problem of overcrowding, poverty, people management, and all those stuff which comes because of the situation what you have in the most populous cities. So this also leads to various kinds of problems. You can report, there could be incidents, there could be fire incidents and all. So today in this use case, we are using the Delhi Fire Services data and also some from the other web sources. And we are trying to analyze how insights for ArcGIS can help you in providing a solution to this crucial problem. So this is the scenario. You know that like last year, Delhi Fire Services attended about 27,000 calls of fire incidents itself. So that was surprising to me, and I'm sure you also will be surprised that such a thing happened. So let's use the smart portal app of ours, the portal for ArcGIS, to discover the reasons where the higher incidents of reporting is happening in. We'll try to find out the patterns and the trends of these fire causes, and we can correlate them with various parameters and see how insights can help you in reducing the future incidents. So Asad, can we have the first map showing up where the fire incidents have been reported? You can see that's a density map which is coming up. So Asad, we have introduced the feature of changing the base maps wherein users can bring in their own base maps. Can we have a glimpse of that? So that's where you can see Asad has brought in a new base map wherein you can bring in your own base maps, and we have brought a dark canvas. So looking at this map, I'm very clearly able to see areas like Shahadra, Okhla, where you can see the maximum reportance of these incidents which are happening in. So Asad, I would now like to see the segments where these kinds of fire incidents are being reported. So you can see the maximum reports are coming from residential. That was a surprise to me. And probably this is because of the statement what we made about like overcrowding in these areas. Asad, then can we now find out what are the causes of these fires which are actually causing it? You would have seen the Insight app last year also. So this is again a new kind of a chart. We call it as a chord chart, which has been introduced. And you can see it clearly shows the electrical short circuits are becoming the major cause of reported incidents. And it's so clear in this graph. You can see the chart gives you a very clear thing about the domestic report and other followed by the other stuff. So this gives me, this is the first analysis of the data which I got from the Delhi Fire Services, gives me a very clean scenario of what are the causes, where you are having the maximum reports to happen. So now let's move on to see the next step of this, what is actually causing and how the rescue operations are being taken in. So in the insights, we have introduced where you can calculate mathematical functions too. This is again a new introduction we got in. You can see Asad is calculating the rescue time in this scenario wherein he is actually doing a very simple mathematical calculation of the reported time versus the time when the vehicle reported there. And he is able to calculate the rescue time. So once he does this analysis and plots it on his map, he is able to clearly find out the areas where the response time was or the rescue time was much. And you can see the areas where the darker polygons are there are some of those places where the rescue, even though the incident was reported, the rescue time got delayed. So let's analyze this further and see which are all these areas where these incidents have been reported. And you can see some of those nice polygon comes up in form of the bubble chart. Now the task becomes to identify the areas where I can carry out these campaigns effectively, where I can place fire hydrants or establish new fire zones, can all be very easily picked up by doing this last step. You can see these are the existing fire tender locations, and those are the areas where the gap lies. See, with a simple click of this button, the Insights is able to give you a resolution of finding the areas of higher incidence, and a quick decision can be taken by the decision makers to find or correlate the newest fire tenders. You know, by this analysis where I'm able to find out where the fire reports are happening and where the fire incidents are happening, where I can locate my new fire hydrant, this actually reminds me of the Delhi Disaster Management Authority statement where it says the fire planning should be also the part of urban planning. Thank you, ladies and gentlemen.
Thank you, Krishna and Asad. Going from lots of data to new insights and understanding to action. That's what Insights for ArcGIS is all about. We're making big strides with real-time analytics as well. This means integrating sensor networks and information from the IoT, observations streaming in at very high rates. This actually is scalable through multiple processors and feeding actually real-time analytics, situational awareness, and alerting, and also being able to save these observations off into this geoanalytic, meaning storing all of the observation data in a spatial big data store. Big data and spatial analytics is also advancing. There are really two types. One is about analyzing big data for features and vectors, to do space-time analytics, hotspots, densities, buffers, and some basic analytics, and doing this on a massive scale. Sometimes 10 times or even many times faster than what's possible on traditional desktop servers. Also scalable to problems that we've never been able to process before. There's also raster and image analytics that also are parallelized, meaning that the processing can be distributed across a cluster of machines, allowing you to do big problems much, much faster. So I'm going to, in the last few minutes here, talk about the actual components of the platform. And of course, we talked before about apps. Apps is what brings the whole platform to life. And so, simply put, there are apps for the field, there are apps for the office, and there are apps for the community. Ability to actually leverage the community for crowdsourcing and storytelling and quick reporting of status to create this community GIS and system of engagement. There are also solutions that are available and open sourced. These are available on GitHub for you to actually just download and use. They're focused on local government, for utilities and telecom, most importantly for emergency management and public safety, and also military and national security. If you don't want to actually use ready-to-use apps, you can actually build your own apps and host those very simply using app builders. This actually is two parts, one for native apps using App Studio, and also the ability to create web apps, browser apps, using the web app builder. It's actually quite extraordinary how the growth of these things is happening. There are over 500,000 web apps and created and deployed using this web app builder. Very, very popular. Why? No programming required, unless I want to. The premier app, actually, for GIS professionals is Arcgis Desktop. We have a couple of apps, of course, ArcMap, that has been the mainstay of all of our work, and also now ArcGIS Pro. ArcGIS Pro is a whole new generation of desktop. It actually is services-based to work in full concert with the WebGIS pattern, and also has new capabilities for being able to do ortho imagery, working with massive point clouds, and many, many other things. At this point, rather than talk about it, and oh yeah, the extensions, of course, are also available, I'd like to call my colleagues Krishna and Pratha back up on stage to actually show us a little bit about how ArcGIS Pro works. Krishna.
Thank you, Dean. Thank you. Thank you, Dean. Ladies and gentlemen, you all know Arcgis Pro is our future desktop, and this is being used, and this is becoming powerful day by day. This has many new functionalities of what desktop was having, other than what desktop was having it. We have now introduced machine learning and deep learning algorithms within the Arcgis Pro, which you can make use of it for doing your predictive analysis. This is the ecological marine data which we are showing you today. The course where we are the demo we are showing in is the ecological marine data of the world, where you can see each and every point is actually representing the chemical composition of that particular place. And you can see this. This is a place where you can have, these are some of the places where you can see the concentration of seagrass too, and each of the composition is known to us with that particular data. So many of you may think why we are talking about seagrass. You all know seagrass is very important for our keeping a balance with our atmosphere. You know, seagrass stores CO2 and maintains the carbon cycle. And it is estimated that about 1 acre of green grass, of the seagrass, can actually habitat about thousands and some crores of vertebrates and invertebrates, and 30 to 300 times more times of CO2. So which is actually more than, which actually does more than the tropical forests. So this actually helps in maintaining your ecological balance. So let's see now for one of the areas where about how he is mapping in. For that one particular area where he is going to go in and will use tools like, we call this as sea fence or the atmospheric fence, which can actually show you the representation of the different concentration of the chemicals there. So in this case of seagrass, we are trying to estimate the concentration of nitrate, which actually can be of a very effective in nature for the growth of the seagrass. So you can see Partha is representing a sea fence wherein it's showing the concentrations of that. So where you can see it's a fence which actually connecting the equal values of nitrates conditions in that particular place. So this actually affects a lot onto your seagrass growth. So now coming to this, let's go on and do the deep machine learning algos classification of this. So we are going to take up some of the known sites where the seagrass is found. So we are going to use this as a training site and put them into the machine learning algos and classify them for the entire world. And let's see how the results come out. So therein you can see in another few seconds, you can see the entire area. These are the places where the seagrass density is high and there seagrass can be found in. So now let's go on and try to continue down onto a particular spot where the highest concentration of seagrass is there. You can see in this, and when I want to look in, so he has applied the kernel density formula wherein you can see the maximum concentration of the seagrass is available. So this shows us the areas of where the green grass is present, where we have to give more emphasis on production of these in order to save our nature. Thank you, ladies and gentlemen.
Well, that gives you just a quick glimpse at some of the amazing capabilities. 3D, 2D visualization, scientific rendering, ties into advanced analytics, all available to you through ArcGIS Pro and beyond. Let's move now to ArcGIS Enterprise. This is actually the next generation server platform. As I mentioned, ArcGIS becomes distributed now. Not just one, but actually multiple. So ArcGIS Enterprise, what we used to call server, is a whole new architecture. Actually, it's also easier to install and deploy through automated scripts, and there's much, much more. This gives you just sort of a quick look at the architecture. What we now have is actually access and management, as I mentioned before, through Portal. And then there are a variety of server roles. The traditional GIS server that we have had, and then also a server for imagery, and a server for GeoEvent, and a server for GeoAnalytics. Each of these servers can actually be scaled up independently to manage the variety of workloads nodes that you have to create performant and more reliable and scalable systems as you begin to work with your entire organization. One thing in particular to note here is how ArcGIS Enterprise also manages real-time events and also the ability to take those real-time events, manage them in a big data store, the spatiotemporal information, and then also be able to activate big data analytics on that big data store. I think what I'm going to do now, rather than just talk about it, is ask my colleague Josh Joyner to show us a little bit about how this works. Josh?
Thank you, Dean. So to start with, I thought I'd share a clip that I took earlier this week on Monday night when we went over to our offices here at the Esri India office, just to kind of set the stage for what we're going to be talking about today. We're going to be talking about traffic. In particular, we're going to be talking about the hazards that occur with crash data. Thankfully, we did not have any accidents. There were no crashes Monday night, but it kind of gives you a glimpse of some of the traffic concerns here in the area. The Transport Research Ruling of the Ministry of Road Transport and Highway Data recently released the 2016 crash data for India. And while for the year, the number of crashes has gone down, unfortunately, the rate of fatal crashes went up for last year. Total numbers for that ended up being 413 fatal crashes per day. That's an average of 17 fatal crashes per hour. And unfortunately, for those of you that are familiar with the area, Delhi also was unfortunately the highest ranked, the highest risk area in all of India. There are initiatives set forth by the ministry to try to reduce these rates. How do we reduce these rates to safer levels? The target set forth has been to reduce it to 50% by 2020. And Esri is working hard to try and realize some of those goals, not just here in India, but around the world, countries that are facing similar challenges. One way we're hoping to be able to do that, I'm excited to announce this week, is a partnership that we have with a company called Mobileye, which is an Intel company. What Mobileye provides is they provide some of the world's best class computer-aided camera systems that can be placed on vehicles, that can do machine learning, they can detect certain patterns. When you combine that alongside Esri's best-in-class analytics and mapping capability, it really is just a phenomenal combination. So the initial thing we're targeting with that, and this is being done through Mobileye's product called a Shield Plus device, is designed to be implemented on things like buses, lorries, other municipal vehicles. And what this does is by placing the cameras around the vehicle, it helps reduce some of the blind spots that are typically present with vehicles of this size. So that when vehicles are turning, or even just pedestrians that may be approaching on the sides, it allows the drivers to be notified about this in real time, both through audio and visual identification, kind of some flashing lights within the vehicles to kind of alert them to these hazardous conditions. And in the case of a potential collision, the point being is we want to alert the driver ahead of time so they have time to react to this. So here's an example of how this would be done. So you have a driver that's driving on their normal route, and the whole time the cameras are capturing these images and sending them through a machine learning algorithm to identify pedestrians and cyclists. Any areas that are within those blind spots. When they approach within a certain proximity of the vehicle, those are switched to be alerting. So here's an example of this running in real time. So we can see in the video captured in the top left, as the vehicle is driving through the city, it's identifying pedestrians, both on the road as well as on the sidewalk, to be alerted if these pedestrians were to step out in front of the road. So in this case, you're about to see here, these people didn't even look. They didn't even look to see that there was a vehicle coming. So that sort of alerting is both the responsibility of the pedestrians and of the drivers. At the same time, though, we're also capturing all of that information. We can bring it into ArcGIS, through Arcgis Enterprise. So we can do some real-time analytics and big data analysis on this data once it's been captured. So there's several ways that we can visualize this information. So an example, as you see here, is actually displaying all of the raw data on the screen. One of the limitations with that is, as you would imagine, for cities like Delhi or Tokyo or New York, the volume of that data that could be collected over a year or several years can just become massive. And to be able to distinguish single points, even 100 points versus thousands of points, it's hard to distinguish from this map. So there are several ways that we provide to be able to get greater insight into that data. One such method is by running spatial analytics. As Dean mentioned, we have a geoanalytics server that allows you to do some of this large batch analysis on the data. So in this case, we're looking for both road segments and intersections with the highest volume. So already looking at the same data set, we have a little better in-depth view of what we have. There's also options to store the data within the spatio-temporal big data store for on-the-fly rendering. This is server-side rendering. So for clients that are wanting to view this on a mobile device in the field, this is very, very performant data. And it's a very easy way to quickly visualize those patterns, those areas with a higher concentration of potential collisions versus those areas that are much lower. And it's important to understand that even though we're capturing all of this information and returning it in an aggregated bin for faster response time, all of the original raw data is still accessible. So if you have pop-ups enabled, you can click on any one of these bins and still be able to see all of the raw data that was captured. Another way to visualize this, both spatially and temporally, is by looking at multiple classifications of the data. So in this case, we're looking at both a given proximity and a time of day. So we have different colors to represent different times throughout the day. Once we have it classified like this, we can then go and look for clusters, certain patterns that have occurred either in a given area or at a given time. So in this example here, showing from New York, is showing that this particular cluster had 286 potential collision warnings at this point. These are pedestrian warnings, I should say. And most of these were occurring in the evening. So we're able to kind of see where the problem areas, where these hidden problems occur for these regions. For users that are wanting maybe a little more impact to view their collision data, sorry for the pun, you're able to also render this in a 3D visualization as well. So we're able to go back, put this into a custom application that allows users to explore the data, be able to zoom in, see some of the different details, and play it back. In this case, we're showing a new visualization style we have, which is called a space-time ripple, that allows you to see changes throughout the day across a given area. So I will take one last second to kind of give a plug to our session tomorrow. We're doing our real-time and IoT summit is beginning tomorrow, so we're going to take a much deeper dive into all of these technologies and hopefully kind of show you how your organizations can benefit from it. So with that, I'm going to give it back to Dean. Thank you very much.
Thank you, Josh. Pretty amazing, actually. Go to the session tomorrow because there's some really, really interesting things that are beginning to roll out and are available to you. ArcGIS Online, of course, is our SaaS offering. This means you need no software at all. All you need is a subscription, and you can tap into amazing capabilities that are there, like smart mapping, the ability to spin up your own feature services, the ability to use 3D scenes. This is becoming a very, very popular system around the world. There are about 4.5 million users on a regular basis. Every day, actually, we serve over 1 billion maps. And actually, this scales up as well. There are two events that really we scaled up to about 4 billion maps a day. This was during the hurricanes earlier this fall. And actually when, well, you know about Pokemon. And, well, there's this Pokemon Go, which was a way to track all the Pokemons. These guys tapped into our system, and all of a sudden, ArcGIS Online became a way to track Pokemons around the world. So, okay, you can use it in the professional world, or you can tap into it for gaming and having a lot of fun. But bottom line is, there are now over 11 million maps and data sets that are registered in the system. So this is actually quite extraordinary. moving into what actually is becoming the authoritative community map. One of the things that is rolling out actually with 10.5.1 and also improves at 10.6 is called portal content replication. This actually is what is taking all of the enterprise information from different types of organizations or different departments. You can use this enterprise information internally for the organization. And then you can actually select specific items and replicate those outside. This is actually how you turn your enterprise information into community information. And this is actually enabling collaboration and sharing across organizations and is the foundation for the system of systems that I mentioned earlier. This actually is also enabling something that a new product that we call ArcGIS Hub. It is the new platform actually for collaborating with your community. It's actually based on policy initiatives. So for instance, this idea of Vision Zero or reducing pedestrian deaths, this can actually be a community initiative where not only are you feeding in the enterprise information like Josh showed just a minute ago, but you also can publish those externally where the public themselves can talk about specific hazards that need to be taken care of, and also communicating out and providing alerts through smartphones and other types of devices to let people know where there's heavy congestion and lots of risk. So I can't really leave here without saying that ArcGIS is also a platform for developers. It is an amazing development platform for those that want to create custom apps and very specialized workflows to enable their organization. The other thing that I want to call out here is something called ArcGIS API for Python. This is actually quite extraordinary. It actually opens up all of ArcGIS for scripting and automation and interactions with all types of systems. So what does this mean? This means actually that you can automate anything. You can analyze anything. You can use any system you want to get the best authoritative content, integrate through Pythonic scripting, and also integrate analytical capabilities from not just ArcGIS, but other systems as well, like these deep learning, machine learning, AI types of systems and algorithms that all work together and can be exposed through scripts and also something new called Jupyter Notebooks. I urge you all to learn more about these things. It's really a whole new generation of opening up the ArcGIS platform. So let me just finish off by saying that ArcGIS actually is open and interoperable and standards-based. There are really three different areas that we pay attention to. First of all, it's industry standards and formats. It also is product integration. We were having a discussion yesterday about being able to link up ArcGIS with SAP for asset management. Well, these integrations are already built in. And then finally is open software, actually providing open access to ArcGIS and open API, like I just talked about with this new Python API. So let me just conclude by saying that it is a great honor and privilege actually for me to be here to share the morning with you and talk about Esri and that our real mission actually is about serving you, our user community, to advance GIS and the science of where. Strong and growing, and we're dedicated actually to engineering and science and bringing all this to you so you can make in the work that you do. We also are putting a lot of emphasis in the next year on professional development. If you're like me, kind of an old GIS guy, things are changing a lot. And so we're introducing this notion of lifelong learning and providing all kinds of resources available online and also through our training resources, Esri Press, MOOCs, and many other resources to allow you to continue to gain knowledge and be able to apply it effectively as your career advances. We also are focused on education, and this is actually about the next generation, ladies and gentlemen. This is actually building the next generation of spatial thinkers to help us advance and continue solving the problems that we have at hand. Many of you contributed and participated in GIS Day, and some of you have actually adopted schools and have become geo-mentors. I urge you to do this. It's actually one of the most rewarding things that as a professional you can do for yourself and for the next generation. So let me conclude actually by saying a little bit about how we take all this to action. Last fall at this time, my wife and I took a trip to Milan, Italy. And we had the most extraordinary day I think I've ever had in the Da Vinci Museum in Milan. This is actually taking the thoughts and how this man actually put them into practice. And Da Vinci said, knowing is not enough. We must apply. And being willing is not enough. We must do. So, ladies and gentlemen, I thank you all very much for all the good work that you do, and I wish you all a great conference. Thank you.